Today we're diving into the world of file handling in Python. Whether you're new to programming or looking to sharpen your skills, understanding how to work with files is essential. Files are everywhere storing data, logs, configurations, and more. Python makes it easy to read, write, and manipulate files, which is a fundamental part of many applications. In this video, we'll explore the basics and gradually move to more advanced operations. By the end, you'll be comfortable handling files efficiently and safely in your Python projects. Let's get started by understanding what file handling actually means in the context of Python programming. Before we jump into code, let's clarify what a file is. In computing, a file is a collection of data stored on disk, which can be anything from text, images, to program data. Files help us persist information beyond the runtime of our programs. In Python, files can be opened, read, written to, and closed using built-in functions. Understanding the structure and types of files is crucial for effective file handling. We mostly focus on text files and how Python interacts with them, but the concepts apply to other file types as well. Work with a file in Python, you first need to open it. Python provides the built-in open function for this purpose. The open function takes at least one argument, the file name. You can also specify the mode, such as R for reading, W for writing, or A for appending. Opening a file creates a file object, which you can then use to perform various operations. It's important to always close the file after you're done to free up system resources. Let's break down the different file modes in Python. The most common modes are R for reading, W for writing, and A for appending. There's also B for binary mode and plus for updating. For example, RB opens a file for reading in binary mode, while W plus allows both writing and reading. Choosing the right mode is essential to avoid errors or data loss. Understanding these modes helps you control how your program interacts with files. Reading from a file is one of the most common operations. After opening a file in read mode, you can use methods like read, readline, or readlines to access its contents. The read method reads the entire file, readline reads one line at a time, and readlines returns a list of all lines. These methods give you flexibility depending on your needs. Remember, reading large files all at once can consume a lot of memory, so choose the method that fits your scenario. Writing to files is just as important as reading. To write, open the file in W or A mode. The write method lets you add text to the file. If you use W, the file is overwritten while A appends to the end. Always be cautious with W mode as it erases existing content. Writing data to files is useful for logging, saving results, or exporting data. After writing, don't forget to close the file to ensure all data is saved properly. Closing files is a crucial step in file handling. When you're done reading or writing, always call the close method on your file object. This ensures that all resources are released and any buffered data is writ to disk. Forgetting to close files can lead to data corruption or resource leaks, especially in larger programs. Python also offers a better way to handle this automatically, which we'll discuss next. Python's with statement is a best practice for file handling. It automatically manages opening and closing files even if errors occur. By using with open file name as F, you ensure the file is closed properly after the block of code runs. This approach makes your code cleaner and safer, reducing the risk of resource leaks. The with statement is highly recommended for all file operations in Python. In dealing with large files, reading the entire content at once isn't practical. Instead, you can read files line by line using a loop. This approach saves memory and keeps your program responsive. For example, using for line in file inside a with block lets you process each line as it's read. This is especially useful for log files or data processing tasks where efficiency matters. Help paths tell Python where to find your files. You can use absolute paths, which specify the full location, or relative paths, which are based on your current working directory. It's important to use the correct path format for your operating system. Python's OS and Pathlib modules help manage paths and make your code more portable. Always check your paths to avoid file not found errors. For opening a file, it's often wise to check if it exists. Python's OSPath exists, or Pathlib path exists. Methods can help you verify a file's presence. This prevents errors when trying to read or write to non-existent files. Checking for existence is especially useful when working with user input or external data sources. Create a new file, open it in Write W or Exclusive Creation X mode. If the file doesn't exist, Python will create it. If you use X mode and the file already exists, Python will raise an error. This feature is handy for generating reports, logs, or exporting data. Always handle exceptions to manage cases where files can't be created. Appending means adding new data to the end of an existing file. Open the file in a mode and use Write to add content. This is useful for logs or when you want to preserve existing data. Appending doesn't erase previous content, making it a safe way to update files incrementally. Not all files are text. Images, audio, and other data are stored in binary format. To handle these, use RB for reading and WB for writing. Binary mode reads and writes bytes, not strings. This is essential when working with non-text files, ensuring data integrity and proper file handling. File operations can fail for many reasons: missing files, permission issues, or disk errors. Python's try-except blocks let you handle these situations gracefully. By catching exceptions, you can provide helpful error messages or take corrective action, making your programs more robust and user-friendly. Sometimes you need to remove files you no longer need. Python's osremove or pathlib path unlink functions let you delete files safely. Always check if the file exists before deleting to avoid errors. Deleting files is a powerful operation, so use it with caution to prevent accidental data loss. Renaming files is straightforward with Python's osrename or pathlib path rename methods. This is useful for organizing files, versioning, or updating file names based on content. Always ensure the new name doesn't conflict with existing files to avoid overwriting important data. Copy files. Python offers the shuttle module with functions like shuttle copy and shuttle copy to. These methods duplicate files from one location to another, preserving content and optionally metadata. Copying is handy for backups, migrations, or duplicating templates. Always verify the destination path to prevent overwriting existing files. Moving files is similar to copying, but the original file is removed after the move. Python's shuttle move function handles this. Moving files is useful for organizing data, archiving, or processing workflows. Always ensure the destination is correct to avoid losing files. Files are stored in directories or folders. Python's OS and pathlib modules let you create, remove, and list directories. Use osmkdir or pathmkdir to create and osrmdir or pathrmdir to remove empty directories. Listing contents is easy with oslister, or managing directories is key for organizing files in larger projects. To see what files are in a directory, use oslister, or these functions return the names or paths of all files and folders in a given directory. You can filter or process these lists to work with specific files such as all text files or images. This is useful for batch processing or organizing files. Sometimes you need to process files in subdirectories as well. Recursive operations let you walk through all folders and files. Python's oswalk or patharglob methods make this easy. This is especially helpful for searching, organizing, or batch processing large collections of files. Python lets you access file metadata such as size, creation date, and permissions. Use osstat or pathstat to retrieve this information. File metadata is useful for monitoring, auditing, or managing files based on their properties. File permissions control who can read, write, or execute a file. Python's oschmod function lets you change permissions programmatically. This is important for security, especially when sharing files or deploying applications. Always set permissions carefully to protect sensitive data. In multi-user or multiprocess environments, file locking prevents conflicts when multiple programs access the same file. Python's third-party modules like FileLock can help you implement file locking. This ensures data integrity and prevents corruption during concurrent access. Temporary files are useful for storing data that doesn't need to persist. Python's tempfile module creates temporary files and directories that are automatically deleted when no longer needed. This is handy for intermediate results, caching, or testing purposes. CSV files are common for storing tabular data. Python's CSV module makes reading and writing CSV files straightforward. You can parse rows, access columns, and process data efficiently. This is widely used in data analysis, reporting, and exporting data between systems. JSON is a popular format for structured data. Python's JSON module lets you read and write JSON files easily. You can convert between Python objects and JSON, making it simple to store configurations, exchange data, or interact with web APIs. Python's pickle module allows you to serialize and deserialize Python objects to and from files. This is useful for saving program state, caching, or transferring complex data structures. However, be cautious with pickle files as they can execute arbitrary code if loaded from untrusted sources. Text files can use different encodings such as UTF-8 or ASCII. When opening files, you can specify the encoding parameter to ensure correct reading and writing. This is especially important for internationalization or working with non-English text. Always match the encoding to avoid errors or data corruption. File objects in Python offer several useful methods beyond read and write. Methods like seek let you move the file pointer, while tell gives the current position. Flush forces data to be written to disk. These methods provide fine control over file operations, especially for advanced use cases. Truncating a file means cutting it down to a specific size. The truncate method lets you shorten a file, which can be useful for clearing logs or resetting data. Be careful, as truncating removes data beyond the specified size, and this action cannot be undone. File operations use buffers to improve performance. Buffering means data is temporarily held in memory before being written to disk. You can control buffering with the buffering parameter in Open. Understanding buffering helps you optimize performance, especially for large or frequent file operations. Managing file permissions is crucial for security. Always set appropriate permissions to prevent unauthorized access. Python lets you check and modify permissions, helping you protect sensitive data. Security best practices include limiting write access and regularly auditing file permissions. File streams allow you to process data as it's read or written, rather than loading everything into memory. This is especially useful for large files or real-time data. Python's file objects are stream-based, letting you read or write data efficiently and flexibly. To write reliable code, follow best practices, always close files, handle exceptions, use the with statement, and validate file paths. These habits prevent errors, data loss, and resource leaks, making your programs more robust and maintainable. Some common errors include file not found error, permission error, and I/O error. These occur when files are missing, access is denied, or input-output fails. Understanding these errors helps you debug and write more resilient code. Always read error messages carefully and handle exceptions appropriately. Python's scripting capabilities make it easy to automate file operations. You can write scripts to process, organize, or analyze files in bulk. Automation saves time, reduces errors, and is especially useful for repetitive tasks like backups or data processing. In real-world projects, file handling is everywhere, from reading configuration files, processing data, to generating reports. Mastering file operations lets you build more powerful and flexible applications. Practice by working on small projects like a log analyzer or a data exporter to reinforce your skills. Different operating systems handle files differently. Python's OS and Pathlib modules help you write code that works across Windows, macOS, and Linux. Always test your file operations on all target platforms to ensure compatibility and avoid surprises. Working with files in different languages requires careful handling of encodings. Python's support for Unicode makes it possible to read and write files in any language. Always specify the correct encoding and test with diverse data to ensure your applications are truly international. Handling large datasets requires efficient file operations. Read and write data in chunks, use generators, and avoid loading everything into memory. Python's file handling tools make it possible to process gigabytes of data without running out of resources. Testing is vital for reliable file handling. Use temporary files and mock objects to test your code without affecting real data. Python's Unitest and PyTest frameworks support file operation testing, ensuring your programs behave as expected in all scenarios. We've covered the essentials of file handling in Python, from opening and reading files to advanced operations like copying, moving, and handling errors. Mastering these skills empowers you to build robust, efficient, and flexible applications. Remember to follow best practices and keep experimenting to deepen your understanding. Now that you have a solid foundation in file handling, try applying these concepts in your own projects. Practice reading and writing different file types, automate tasks, and explore Python's modules for even more functionality. The more you work with files, the more confident and skilled you'll become. Happy coding!